Hi everybody, Adam Savage in my cave, and we're going to do some lathe improvements today. Frequently on the lathe, I need to take an indicator measurement of exactly how concentric what's turning on the lathe is. That means I need to put an indicator on either what I'm spinning or on the chuck that I'm using and zero them out, make them super precise, or know exactly how far out of round they might be. There are lots of indicator holders that one could buy. I never thought that 3D printing would yield a proper indicator holder, but this to me looks like an excellent Multifix B, which is the quick release tool system I have, Multifix B. This looks like an excellent Multifix B holder for an indicator. I use mostly these 3/8 inch shank indicators, and so this will sit in here, comme ça, like that, and it will take a reading from how round something is on the lathe. Oh, what is this? What is this little nubbin of goodness? Oh, this comes from a Reddit thread on our machinists of like, what is your favorite master car order? And there's some great stuff. We'll include a link to the thread in the description because there's some really great stuff in there, including, I'm not even going to spoil it. Go to the thread. But this, an indicator tip with a ball bearing. This isn't going to get you to micrometer level accuracy, but it will average out the out of round that your thing is and really allow you to. The more sensitive your indicator, the more prone to noise it can be, and it's hard to see a signal within that noise. This is a lovely way to help eliminate some of that noise. But, so I've been talking about indicator holders here. So that is what I hope this will end up being, is a proper, useful indicator holder for my lathe system. It needs a few things. It needs some tapped holes here. It needs a tapped hole here and a bolt here for tightening it down. I'll probably throw in some helicoils in this. Also, it needs to have this bolted on and another helicoil put in here to set the depth, because you always want your tools to be hitting your lathe precisely on center. You might not think that it is mission critical, because if you are just feeling it out, it's not necessarily mission critical. But if you are measuring anything, you want to measure to the absolute horizontal plane that cuts through the center of whatever you're spinning. Because anything less than that, and you've got a tangent to the radius, and it's not a true radius, and you're cutting, and so your DRO, which is accurate to a 10,000th of an inch, is not going to know what you're cutting into because you're cutting under center, which means it's not going to line up with the measurements that you think you might get after cutting X amount. Anyway, this is the attachment for setting a Multifix holder on the correct depth. And I'm gonna thread it, put in some helicoil, do all of that. And then there's another lathe tool that I'm gonna do a little bit more of an elaborate modification on, because it's cool. All right. Yeah, I'm gonna gather some things. So I'm going to take these over to the drill press and drill them out to receive the 1/4-20 helicoil threads, which are these guys. These are thread replacements that are stronger than normal threads. So I sink these into here, and it'll make a very robust attachment system. This is the tap for those, and the tap drill is loaded into my drill press. Let's go. You want to go slow when you're drilling with the PLA. It heats up quickly. I set all my tools on their slowest settings. All right, but here we go. All right, you put in the heel coils with a heel coil insertion tool. That's what this looks like. And you thread it on that little bar there at the bottom. Yep, and then you just use that to twist it on in. All right. Yeah, none of that worked whatsoever. And they do not twist back out. So that is a complete loss. Well, I'm glad to show you how helicoil works. All right, I got to order some more 1/4-20 because these are faulty or weird in some way, and I'm not happy about that. All right. Let us see if these are slightly more cooperative. I must have bought them from some Z brand. That's how they're supposed to go in. Much easier. The others were all distorted. Great. All right, I'm going to get one of these out today. I'll have to do the other one tomorrow. Okay, now these should thread really nicely. And they do. Now, that little thing that you hinged on here, you got to get it out, and that's really easy because you just get to hit it. You just get a kind of a wacky whack. Because the material that the threads are made is so hard, it shatters the moment you, it's great. Okay, so then order more 1/4-20 heel coils. And then we've got some 5/16 18. I'm happy with that. So then there's these. Oh, right, I got to drill these out for 1/4 inch. While we're at it, I'm also going to drill this out for the tap for a 5/16 18 heel coil. I'm running my drill press at about 400. Every time you use a helicoil drill bit, you got to pull it back out of the machine and put it back in your bin because you don't want to misplace these or end up storing them in the general population of your drill bits. So now we're gonna, to have access to this, I'm gonna put this on here. Why am I using the flathead 1/4-20s? Because there's a good reason I'm using these flathead 1/4-20s is because I obtained about 100 of them in stainless steel. And they're not for every project, but for this one, they're totally fine. Hello? There you go. Oh, that's great. Nice. Nice. Okay, so then that can go here, but first we're going to tap it out. Same mechanism. Same mechanism. There it is. Comes up there, grabs there, comes in here. And then you just go right until the top of the first thread sinks below the surface. Then you're pretty safe. And it was the ideal length for this. And here you can see the little nubbin that needs to get tapped out. So here we go. All you got to do is give it a little whack. Wait. Okay. All you got to do is give it a little whack. And it goes away. Then we stick our 5/16, 18. Oh, wait. I know one more way to make this awesome. Yes. Hold on just a second. I'll be right back. This is a cap head thumb screw creator. So it's you put a cap screw in here, and then you put it in a vise like that one. And you put your cap screw and your thumb screw, right, like that. And then you just start pressing them together. They self-align, and when they join, that tells you when to stop. And dude, you get a... Yeah, look at that. I love these things. All right, so now we've got that and this. That's great. Oh, right, I need a nut on there, right? That nut is for the level set. This is awesome. Now we need to make a little locking nut to hold on to the indicator in that hole, and that is a 540 cap head screw with a nice hole they made. But first I need to through drill it to that spec. All right, this is the one. Got this old beautiful Tumico. Excellent. And nice and tight. And then we're going to pull off the probe, the round tip here, and we're going to replace it with this roller. There we go. And that is a completed 3D printed indicator holder. Let's go take it over to the lathe. Let's take it over to the lathe and take a look at it. I know that 3D printing might not strike you as the most solid way to do this, but honestly, for these measurements with such a big piece like this, it's pretty stable. It's a pretty reasonable way to take a measurement. So here's how this will go. Like that. And then I can chuck something around in there. Let's do that. I've arranged a situation in which I can't get the clearance to come see this bloody thing. Hold on. There we go. Yeah, much better. Okay. So here you can see this one's about 30 thousandths 35 thousandths out of round. This is a piece of PVC pipe. There's no reason to expect that it would be perfectly centered. We can actually take another measurement of something that is likely to give us a reasonable reading. And that would be the edge of my big nose, my live center big nose. And if I bring that to 0, that should actually give me a run out of very little. Look at that. About a thou of run out all told. And that might be less if I clean it. Look at that, it's less. All right, so there she blows. A really, really useful bit of kit for my lathe. It would have been easier to show you if I had the left-handed one as opposed to the right-handed one, because you kind of need both. But I am really delighted to have an indicator that lives in here. This will live up here where my stuff goes. Yes. And now there's another thing I wanted to talk about. Okay, so this system I have here, this is called the Multifix, and it is originally Swiss, from my understanding, and it is one of the in my understanding it is one of the two most common quick change tool solutions for lathes. The other primary one being these guys, Aloris, and I cut my teeth on Aloris tool posts. That's what Jamie's got on his Shenhua 1540 tool room lathe. And in the special effects industry, most of the machining is largely aesthetic. Within the mechanicals and the animatronics folks, that's totally different. But like at ILM, when you're making models and you're using the machine shop, you're not making highly crazy precise measurements. You're making aesthetic stuff. You're machining stuff to go together. This is a long way of saying that there are a multitude of cutting solutions and bits and boring bars and tools that you can apply to work on the lathe. And then there's the Aloris Universal Head. This is an insert tip head that is super adjustable. And it's got a little rosette underneath it here. You can see it there. And it clicks in to many points. And I will tell you that in a special effects shop, in the special effects shops I've worked in, this was almost only ever the tool that was in the lathe. This is the most useful to the kind of garbage machining that that we do in the aesthetic part of the film industry. I don't mean garbage without affection. I just mean the kind of, it's machine operation. It's not machining. And I don't make a distinction. Let me make it clear. I'm a machine operator. I am not a machinist in the grand scheme of things. But this is an incredibly useful, universal tool. And they don't make one for a Multifix. So what is a boy to do? Well, I'll tell you what I did. I put one in my Multifix by basically taking a piece of steel. The only reason there's a hole here is because the piece of steel I had a hole in it and I didn't think it mattered. So I took a piece of steel and I drilled a long hole through it, and I'll show you what it looks like. There we go. So I took a tool like on this tool post and I put it on my own tool post, right? I only rescued the front part. So I rebuilt on this one, the back part. And this back part now allows this to be really nicely clamped into a Multifix kit. Why am I telling you this if I have it already built? Because I'm going to build a second one. Because you kind of always want two of these. Look, when you're milling in, you want it to be facing this way on your tool post, but when you're milling this way, you want it the opposite way on your tool post. And my value here in the shop, let me zoom out even one more second. Every shop is a philosophy. Every shop is the externalization of a philosophy of how to work. That might be a group-led philosophy. It might be an individual-led philosophy. Every shop I've ever been in has demonstrated ideas about working in its organization, in its cleanliness, in its layout, in its everything. And I've been saying that for years, but only in the last couple of years did I start to ask myself what my shop philosophy is. And I realized it is the shortest possible distance to the flow state. And when I want a flow state, literally swapping this around in the Multifix is it's annoying to me. I don't want to do it. So I'm making a second one of these so that I don't have to do it, so that I can actually pop this into a new one of these, and then I can have a right side and a left side Multifix holder for my Aloris universal tool head. I've got a lovely, lovely piece of steel right here that should suffice beautifully for this. Yeah. Let's get to the bench and we'll talk about exactly how we're going to go about doing this. Okay, I found a better piece of steel to replace, and here's the thing: the piece that I had, I want as large of a mating surface between this the holder for the universal tool head and the head. I want to maximize the frictional relationship between those two things. And why that seems, well, like losing a 1/4 inch up here or 3/8 of an inch might not be that big a deal. It's probably not, but this is a bread and butter tool. Oh, right. I'm not even sure I got to the reason that these are, in special effects, the tool that almost never leaves the lathe. It's because you can keep indexing, I'll just state the obvious, it's because you can keep indexing the head. You can do flat cuts, you can do straight cuts, you can do relief cuts for threading, you can do internal chamfers, external chamfers, all with the flick of an Allen. That's why these are bread and butter heads. And so I am not going to rely on, I'm going to rely on the maximal relationship I can, and I have this piece of heavy stock, which is just a few thou thinner than this piece, which should be great. And this one's done like several years of great duty for me. So I am going to cut, I bought this stock to make clamps with for my rotary table. So I'm going to fire up the automatic hacksaw. Yeah, you haven't seen it in a while. Let's fire up the automatic hacksaw and cut some chunks. There we are. Now I've got two. This is the new one. Let's go test it out, shall we? I am very, very pleased. That is 2 Aloris Universal heads. I know, an embarrassment of riches. It's ridiculous that I need this much, but I do, and I'm so happy. This one's a little bit smaller than this one. I know I didn't do the final cleanup on it. That's where we're at today. Thanks you guys for joining me today for these 2 little lathe operations. See you next time.